Welcome to Selection Sathi. Today we learn the C++ Standard Template Library or STL vector, map, set, stack, queue, and key algorithms. STL is what makes C++ competitive programming possible and is heavily tested in interviews. Let's dive in. First concept, vector, the dynamic array. Vector grows automatically as you add elements. Pushback adds to the end in amortized O of 1 time. You access elements with bracket notation, v bracket I for O of 1 random access. v dot at of I does the same but throws an exception if I is out of range. Pop back removes the last element. Size gives the count, and empty checks if the vector has no elements. Internally, when the vector is full, it allocates a new array with double the capacity, copies everything over, and frees the old one. This doubling strategy keeps pushback amortized O of 1. Second concept, map, the ordered key-value container. Map stores key-value pairs sorted by key. It's implemented as a red-black tree. Insert, find, and erase are all O of log n. You can insert with m bracket key equals value, but beware, if the key doesn't exist, this creates a new entry with a default value. Use m.find or m.count to check existence without accidentally inserting. If you don't need ordering, use unordered map which is based on a hash table, average O of 1 lookups, much faster for large datasets. Third concept, set, the unique sorted collection. Set stores unique elements in sorted order, also using a red-black tree. Insert adds an element only if it's not already present. Count returns 0 or 1. Erase removes an element. All operations array O of log n. If you need duplicate elements, use multiset. If you don't need ordering, use unordered set for average O of 1 operations. Set is very useful for removing duplicates from a collection automatically. Fourth concept, stack, queue, and priority queue. Stack is last in first out LIFO. Push adds to the top, pop removes from the top peaks at the top element. Used for depth first search, expression evaluation, and undo operations. Queue is first in first out FIFO. Used for breadth first search and scheduling. Priority queue is a max heap by default. The top element is always the maximum. Push and pop array O of log n for a min heap. You declare priority queue of int, vector int, greater int. The greater comparator reverses the order so the smallest element is on top. First example, vector operations. We create a vector with 10, 20, 30. Push back 40, push back 50 gives us 10, 20, 30, 40, 50. Pop back removes 50, leaving 10, 20, 30, 40 with size 4. We iterate with a range for loop. For auto v, print each element. Output 10, 20, 30, 40. Clean, simple, and type safe. Second example, map, insert, and iterate. We create a map of string to int and insert Alice 90, Bob 85, Charlie 92. When we iterate, the output is in alphabetical order, Alice 90, Bob 85, Charlie 92. The map automatically sorts by key. To check if a key exists, use m.find of Bob. If it doesn't equal m.end, the key exists and we can access its value. Third example, sort with custom comparator. We have a vector 3, 1, 4, 1, 5, 9 sort of v.begin, v.end gives ascending 1, 1, 3, 4, 5, 9 for descending, pass greater int as the third argument 9, 5, 4, 3, 1, 1. You can also use a lambda bracket of int a comma int b returning a greater than b. Lambdas are great for complex custom sorting logic. Fourth example, priority queue. For a max heap, we declare priority queue of int and push 3, 5, and 1. The top is 5, the maximum. For a min heap, the declaration is longer, priority queue of int comma vector int comma greater int. We push the same values, 3, 5, 1. Now top returns 1, the minimum. Min heaps are essential for Dijkstra's algorithm and finding the k-smallest elements. Quick tips. Tip 1. Use v.reserve of n to pre-allocate vector capacity. When you know the size, avoids reallocation overhead. Tip 2. Prefer unordered map over map when you don't need key ordering. O of 1 beats O of log n. Tip 3. For min heap, remember, priority queue with greater int, greater gives smaller first. Tip 4. Sort uses intro sort which guarantees O of n log n. Use stable sort when equal elements must keep their original order. For more concept videos like this, download the Selection Sathi app. Like and subscribe. Thank you.